Our next lecture for Property Surveying CET 40400 is entitled Evidence and Technology. We'll be working primarily out of Chapter 4 of our course text, Evidence and Procedures for Boundary Location, and that's the current edition that we've cited in the past lectures. And the PDF handout files of these lecture slides are available for you to download and use to benefit you with this lecture. Regarding the contents of the lecture, we'll go over the following materials that you should understand upon completion of the lecture. We'll start out with principles to be applied to modern technology, and then get into applying technology to evidence. We'll talk some more about original corners controlling and original surveys controlling. We'll talk about how standards of creation control retracements, get into the errors in original surveys, the effect of standards, original corners based on evidence and not new measurements. We'll get into original evidence superior to modern measurements, talk about technology and setting lost corners. We'll get into coordinates in corners, corners controlling over lines, get into the principle of 2 points or corners make a line, and finish up with a discussion on using modern technology wisely. This is a very important topic in today's land surveying world, as we are in an age where our profession of land surveying has been revolutionized by technology. The way that we measure and really the methodologies that we use to complete our surveys today are very different than what we've done from just a few decades back. And this has really, I think, caused some confusion in land surveying, and particularly with some of our younger practitioners who are coming in without having a strong background in using some of the more, what I consider traditional methods of measuring, with taping and turning angles and measuring lines and angles the way that we had for such a long time, and using modern technology to replace that. And unfortunately, there's a loss there into the importance of understanding what those modern measurements are all about. And that's what this chapter is all about. And let me make a disclaimer right away. I am in no way putting down technology. I think that the surveyor has always been one to step up and use technology to the best level, and it's just a matter of understanding what technology is doing to us. We have to look that our tools have changed, not the overall process of what a survey really means. So in the first section there, which is the introduction section of the chapter, they start out by again talking in generalities about what evidence is. The textbook says that evidence has generally been described in very simple terms. To paraphrase the descriptions proffered in various legal publications and numerous legal decisions in the several states, the practicing surveyor has been cast into an entirely new world of evidence that he or she may not understand and may not be prepared to enter. Evidence that ultimately identifies the position of the original boundary lines and corners, other than the original evidence of boundary corners and lines utilized to locate or prove corners and the resulting boundary lines controlled by these corners, is a combination of the totality of all the evidence. And in that first boxed-in statement there in the text, it says that in retracing boundaries, the totality of the evidence must be evaluated. Only the original evidence is absolute. All other evidence is secondary and is not controlling. They go on then to say that all primary and secondary evidence must be correlated to writings that created the evidence of the original boundaries, which must be within the chain of title. And our next statement that's boxed in says that relocated lost corners and boundaries that are determined by modern precise means can be no more precise than the instruments that originally created them. So we're already starting to see a tie between measurements that we make today and the precision of those measurements in comparison to the measurements that were made originally with more antiquated equipment and the precision of those instruments. The textbook next states that when evidence fails to prove the original corner position, then and only then can the surveyor disregard the evidence and rely on measurements alone. And this is something that I think will become very clear to you as we work through the other portions of this course. They go on then to say that original corners and lines do not depend on technology for accuracy. Accuracy is determined by the law. Law has deemed all original corners accurate regardless of their precision. And it's important here to remember the definitions of accuracy and precision that we've talked about in past classes. And then the text explains these statements by saying that lost corners that are created by methods of greater precision other than the original methods can be no more precise than the method that created the original corners and boundaries. The application of modern technical methods of either greater precision or methodology than those that created the boundaries does nothing to increase the accuracy of the original corner positions and line locations. It does, however, aid in the subsequent retracement of those lines with more modern equipment. A way that I like to demonstrate this with just a basic example is to think about how over time we've retraced or measured, say, the north line of a section. And I've got a drawing here that says that we've got the north line of section 10, and that there was original monuments, of course, as we know from our systems class, that were typically set at the section corners. We'd have, in this case, the northwest corner and the northeast corner, and as well there would have been a monument set at the north quarter corner. So we know that the original surveyors that laid these out, the GLO surveyors, if you will, believed that what they did was laid out 3 points on a straight line, and that the middle point, the quarter corner, was at the midpoint of the line. But with the methods that they used to measure, they might have had reason to believe that that was the case. But when we come back out there today and measure those lines and measure the evidence of those original corners, we find that it is not one line, it's actually two lines, and very rarely does that quarter corner, if ever, fall on the midpoint of the line. So we need to consider the measuring techniques and processes over time. And I've got 4 stages there. We've got the original survey that was done with a compass and chain. And we think here not just about the instrumentation and equipment that was used, but also the measuring conditions. And the surveyors that were making these measurements didn't have nearly the education and training that the surveyors of today have. But let's just focus now on the measuring equipment that was used. There would have been a retracement at some point with a transit and tape. What you should recognize here is that the measuring process would still require the surveying crew to measure along the line, so they would still be in a position to be walking and measuring along the same line that the original surveyor measured and walked on. Then we got into a really different age when total stations were developed. Now we could set up at one point and shoot long distances up to a mile, depending on the instrument that you would have and the conditions that you would have to measure. And so it might be possible to measure from the northwest corner to the northeast corner and pay little attention to the quarter corner in the middle. Or even if you did set a control point there, we still wouldn't be taping, say, past the evidence. I always mention here when I use this in, say, a seminar, that with the original methods and even the first retracement method there, we had to tape past the evidence. We had to tape the line, so we had to walk the line of the original surveyor. And of course today we have GPS, and in that retracement with GPS, we're going point to point. We're no longer concerned with distances, and so we're not going to go along the line and look at the evidence that the original surveyors may have indicated along the line if we looked at their original field notes. We're going to hopscotch, if you will, from one point to the other. And it would seem obvious to me that this methodology could cause the diligence and the efforts involved in the searching for the original monumentation to be significantly diminished when compared to some of the other methods. So this is something to think about and use in the back of your mind as we go through some of the issues and principles and statements that are going to finish out this lecture. Section 2 of the chapter goes over all of the legal principles that are going to be spelled out in the sections that follow, but I want to jump there to the sections that are after the principles are laid out and look at some of the other statements that are made there. There's a boxed-in statement there that says that technology cannot be a substitute for legal principles or law. The textbook goes on to say that when survey practitioners determine that new technological methods can be used as substitutes to replace accepted rules or statutes that are exclusively reserved for the courts, this will place a false sense of security on the surveyors who cast aside accepted rules to rely on such technology. I want to briefly look at what's included in Section 4.3, which is applying technology to evidence. There's a boxed-in statement there that says technology is not evidence, but evidence depends on technology in its creation and future retracement. I want to reread that. Technology is not evidence, but evidence depends on technology in its creation and future retracement. And after that, the textbook says that the foundation or basis of evidence is twofold. First, in its creation, and second, in its retracement or its re-identification after it's once created. We've already talked in this course about the importance of original corners, and so it shouldn't be a surprise to you that that's where we're going to start here with what we're talking about here with our topic of this lecture. Section 4.4 is original corners control, and here we have principle number 1 for chapter 4, and it reads that all original corner locations or positions are a product of two measurements, A, angle or course, and B is distance. And they go on there to quote from a very early textbook by an author, John Love. It goes all the way back to 1688 when he wrote in his text Geodasia, "There are but two material things toward the measuring of a piece of land to be done in the field. The one is to measure the lines, and the other is to take the quantity of an angle included in these lines, for which there are almost as many instruments as there are surveyors." He went on to state that there are almost as many methods of measuring angles as there are surveyors. Accepting the fact that a line is a component of an angle and a distance, which are products of measurements and errors, both elements need to be considered, not just one. We have talked already and will continue to talk about original surveyors and retracing surveyors, and I've mentioned in other courses that most of the time in our era of surveying we're retracing surveyors because we're at least at one point or another on a parcel, even if we're creating a new parcel, we're retracing lines that have been laid out by a previous surveyor. So what we need to take away from this is what our responsibility is as to being retracement surveyors, and that is identified here at the very end of section 4.4. It says the responsibility of the retracing surveyor is twofold. 1. Verify the evidence of the original surveyed lines and create new evidence for new surveyors. And 2. Resurvey and describe the lines in accordance to present-day standards while making reference to yesterday's results. Section 4-5 now gets into the original survey itself, and it's entitled Original Survey Controls. And here we have Principle 2 that says when once created, all corners and lines created by the original survey are without error in a legal sense. And they go on to say there that although the United States public land systems systematize the mode of surveying of vast areas in the public domain, it also has had lingering and legal effects on the metes and bounds systems of surveys that dominate nearly a third of the states, primarily the colonial states and Texas, as well as many surveys conducted in the public domain. And what they're referring to here is the doctrine of the original survey that came through and was emphasized and really made part of law as a result of the public land surveys. And that is that the original survey was without error and that the original monuments control. And the problem we have with today's technology is that we have such a sense of precision, and I'm going to use the word accuracy probably incorrectly here, but accuracy also with our technology and the way that we measure, that we get a sense of believing that we're doing a better job of laying the parcel out than the original surveyor did. And the way I like to say it is that we always have to remember that our charge as retracement surveyors is to put the parcel on the ground where the found evidence shows that the original surveyor put it, not where we think that the original surveyor should have put it. In the next section, Section 4-6, it gets into standards of creation controlling retracements. And we have Principle 3 here that says that all corners and lines created by the original surveys should be equated in relationship to the standards of precision that were in effect at the time the lines and corners were created. And this is an interesting topic because it talks there, if you read the text that follows the principle, it gets into the rapid change in technology in our generation of surveying. It says there that within the present day's surveyor's lifetime, we have seen the technology chain from the staff compass and link chain to global positioning units. And by contrast, a line run by a staff compass could be expected to create an angle measurement precise to about 1/4 of a degree of arc, and a distance measurement was precise to 1 chain in a mile, with the corner being established at the end or termini of the survey measured lines. Today's global positioning units create the endpoints first, and from the created points calculate the lines that were not run. This becomes a legal problem in that the law provides that the lines run on the ground indicate the intent of the boundaries of the creating surveyor as indicated by the endpoints or corners and lines created by the original surveyor. The corners and lines created in the original survey provide the final question for the retracing surveyor to answer, quote, "Am I following the lines that were originally created?" And they go on to say there that they're not advocating there that we have to throw our technology away and go back to the old way of measuring, but that we do have to understand the relationship of distances and angles that resulted from historic original measurements and descriptions. And read through the example that they give there over those next couple of paragraphs to accentuate just what's being stated here. Next we get into section 4-7, which is errors in original surveys. And we have principle 4 here, which states that any error present in the original surveys will be in either direction, which is bearing, or distances. And these two error possibilities should not be considered to be in a direct relationship to each other. Errors may also be found in words. And later on in that section, they have a boxed off statement that says all original corners have a positional tolerance location. We know a lot today about positional tolerance and positional accuracy, or whatever else you want to call it. And we've worked with those words, and we'll work more with those words in future lectures in here. But we have to realize that even in the times of the original surveys of the public lands, there was some statements of positional tolerance that were dependent on the times that the measurements were being made and dependent on the equipment that was being used. And as you read through this section 4-7, you can see how some of those tolerances relate to the tolerances of today. And you would expect that those tolerances back then would be much looser than the tolerances that we have with our measurements today. So what we have to understand here is that these measurements that were made with the results that came out considering the tolerances were acceptable in that time because of the tolerances that were in effect. Staying within this same general topic, we have section 4-8, which is effective standards. And principle 5 here says that each error should be independently considered in relationship to the standards that were in effect at the time the line measurements were created. Goes on to say, in analyzing found evidence, the relationship of the found evidence to the measurements should be to the standards in effect at the time the measurements were conducted and not to the modern measurements of today. Applying this principle permits the surveyor to exercise latitude in accepting or rejecting evidence to prove the existence or non-existence of a corner position. This also will permit the retracing surveyor to exercise personal initiative and experience in evaluating evidence and in accepting this evidence. In many of the courses I've taught that where we start getting into standards and measures of accuracy and positional tolerance and the like, I stress the fact that we have to put ourselves back into the time that the original measurements were made and consider certainly the technology that was in place at that time, since that's the focus of this particular lecture. But you also have to take into account the working conditions that were there, the types of measurements that were being made, and the overall education of the surveyors that were doing the work. And as time has gone on, the conditions have gotten somewhat easier for many of us because we're working in urban areas now rather than in rural areas, and developed areas rather than undeveloped areas. We know all about the technology increasing, we've talked about that, but the education that even our technicians get today is superior in relationship to the education that the surveyors of yesterday had. So all those things have to be taken into account when you're analyzing your precision of your measurements today in relationship to the precision of the measurements of the surveyors of yesterday. In section 4.9 we have a topic, short section here, but it's original corners based on found evidence and not new measurements. And we start with principle 6 that says the positive position of the original corner location or positions must be predicated on the recovery, identification, and interpretation of original evidence and not on applying modern measurements by the retracing surveyor. Go on to say here that the courts have been stung several times by the misapplication of technology data from experts. Although judges may have GPS units in their automobiles, this does not assure that the judge will not get lost. It will assure that if the judge does get lost, others may be able to tell him or her to 1/4 of a foot where they are. And believe it or not, that's taken from a court case from 1993. You can see the citation for that at the end of the chapter. This places a survey responsibility on both the creating surveyor to leave sufficient evidence behind and the retracing surveyor to know what to look for and then to understand what was found. And then we have section 4-10, which is original evidence superior to modern measurements. And they have a boxed off statement there that says that modern precise measurements yield to original evidence of found and proven corners and lines. The text goes on to say there that there is no retracement principle that permits a retracing surveyor to disregard found original evidence or to change original measurements. If evidence of the original survey is recovered and identified at a position that modern precise measurements indicate that it theoretically cannot or should not be, the retracing surveyor is obligated to disregard that position and give the greater weight to recovered evidence. It is easier for the untrained surveyor to rely on modern measurements that do not have to be proven than it is to place his or her professional reputation and career in jeopardy in having to argue the evidence recovered. Section 4.11 now starts to talk about technology and setting lost corners. Hopefully what we're going to be seeing here is that there is a use for technology, and we're not by any way, as we go through this chapter, saying that using the newer technology is a problem and that it's something that we should avoid. It just spells out what we should use it for and what we shouldn't use it for. And I think many of you will agree that the new technology is really being used incorrectly in many ways when it comes to identifying corner locations. But it does have its advantages. And Principle 7 says that a surveyor cannot use more modern, precise techniques and measurements of a course or angle and distance to set a lost corner, but only as supportive or combative evidence in support or in contradiction of lesser evidence. It says here that this principle places a degree of responsibility on the retracing surveyor in that it first places a large responsibility on the retracing surveyor to understand the degree of proof for the evaluation of evidence and how this should be applied to the evidence found and how new technology should be used in replacing lost corners. And they say here that the beauty of new technology is twofold. Coupled with an understanding of the precision of the original surveys and then applying this understanding to the found evidence, a more precise modern measurement can be used to support weak and questionable evidence. 2, it can be used when a decision is made to accept the older evidence as the best remaining evidence of the original corner position. A more modern measurement can be used to identify the position more precisely that could be an aid for future recovery. And 3, it can be used to refine the original measurement to modern relationships. So the question here isn't, as I stated earlier in the lecture, if we should or should not use new technology to measure. Those are our tools of today. But the question here is, are we going to use those as tools, or are we going to use those as decision makers and throw out the other aspects of boundary surveying, which is the recovery of evidence? And now we get into section 4-12, which is coordinates and corners. And this is a topic we could probably talk about for a long time. We're going to really hold it, for the most part, for what's included in the text here. But this is something that I've brought up and thrown into conversations, not just in classes, but in seminars. And this is an interesting concept and an interesting topic that is probably going to be discussed for a long, long time. Principle 8 says that an original corner, once created, cannot be replaced or redefined by coordinates created by modern survey calculations and measurements using more precise modern methods. And before I get into what the text says here, we all, I think, understand and can recognize that a lot of the methodologies that we use to survey today are based on coordinates. We often measure to create coordinates. We often measure to set points at coordinates. And the location of the corner, in many cases, has come down to a northing and an easting, or to some state plane coordinate that somehow we've defined through computations based on measurements we've made with GPS or other modern technology. So having said that, let's see how the authors address this. It says, with the advent of computers and accompanying ability to write software to accompany the rapid ability to complete computations, surveyors are relying more on the computed evidence than on the solid evidence found while retracing original surveys. Recently in a trial, 2 surveyors were testifying both as experts as to the validity and reliability of their measurements and computations. The basic question was, is a measurement indicated on the plat as 231.14 feet better than one indicated as 231.136? Neither surveyor understood that the validity of the computed measurements is only as good as the field measurements. One distance was generated from a field measurement and the other from a GPS reading. The surveyor with the 231.14 feet measured it using an EDM, measuring a random line between 2 corners, and then calculating a straight line between the 2 non-visible distant points, while the second surveyor computed the coordinates from the 2 coordinate values from a GPS measurement between the 2 occupied corners. Questions must be answered by the surveyor as to the validity of the corner points being measured between, the precision of the original field measurements, and the program used to compute the measurements. None of these were asked. In retracing original measurements, most of the measurements indicated in the ancient descriptions are not balanced measurements of bearing and distance, but most likely are the original field measurements as they should be. So this is where we're really taking ourselves down a road where we have to be careful. And it's so common today to find 2 monuments at a corner, marking a corner, that are almost touching each other, and sometimes they are touching each other, or one on top of the other. And we really believe that we can measure with this much precision to call somebody else wrong. And this is, to me, the strongest evidence that technology is being misused today from a boundary survey standpoint. This is probably one of the most important sections in this chapter, I think, that you're going to read, and I think you really need to take this to heart and understand what's being said here. And that, I mean, when I read this account of this trial between these 2 surveyors that were testifying, I think it's ridiculous, absolutely ridiculous, that we have to discuss the validity of 2 measurements to one another when they're only 0.004 of a foot apart. So you can see where we're going with this and where this thought process of the use of this technology is taking us. We get to section 4-13 now, which is corners control over lines. Corners cannot be proved from evidence of lines found. I'm reading principle 9. But lines are determined from the corners found. There are some surveyors, attorneys, and judges who unknowingly attempt to use lines to prove corners. These few individuals do not understand that without two proven corners, one on each end of the line, one cannot identify or prove an original line. And once again, we refer here to the book Geodasia by John Love, where he defines both a corner or a point and a line as follows. And it says that a point or corner is that which hath neither length nor breadth, the least thing which can be imagined and which cannot be divided, commonly marked as a full stop in writings thus, and they show a period. A line has length but no breadth nor thickness, and is made by many points joined together in length, of which there are two sorts, straight and crooked. This definition once again leads us to the realization that measurements create points, and it is the use of these points in placing monuments and referencing in descriptions that the points become corners. The corners in turn control future locations of the boundaries. But in order to have a line created, the surveyor must have a minimum of 2 points, one at each end of the line. This is the minimum to create a line, and to absolutely locate the created line, the same 2 points must be recovered. And then we get to section 4-14, which continues the theme that was discussed in 4-13. This particular section has the title of 2 points or corners define a line. And principle 10 here says that an original line cannot be ascertained from a single corner, but the line must be determined from proving 2 original corners, one on each terminus of the line. And the text goes on to say that, as discussed, to have an absolute location of an original line, the 2 original corners that were established on each end of the line must be recovered and identified from reference to the original evidence. Without 2 original points or corners at each end of the line, the retracing surveyor must resort to evidence plus 2 independent and separate measurements in 2 directions from that original corner. And if you think about the methods that are prescribed in public lands instructions for single proportionate measure and double proportionate measure, that's what they're referring to. And if you read the rest of that section, they've got an example there to help you through this particular section. And then in section 415, we have a section that talks here about using modern technology wisely. And we've actually got 5 principles included in this section, and I'm going to read through those with little comment on them and have you read through that entire section so that you can tie everything together. First, principle 11 says that an original line cannot be ascertained with certainty with reference from or to a single corner. That's a continuation of what was covered in the last 2 sections. Principle 12 says that in order to conduct measurements for replacing a lost corner, the retracing surveyor should obtain the notes of the original survey. That would help to provide evidence so that areas where search for evidence can take place could be possibly clearer. Principle 13 says that any retracement of boundaries must be predicated on locating with certainty the evidence left by the creating surveyor. A retracement is not a matter of going into the field and, quote, just looking for evidence. It is a task of knowing what to look for. One must have the original created information in order to have the information of what to look for. Failure to obtain and use this information may raise the question of negligence. And then principle 14 says that a coordinate value computed from bearings and distances is less precise as were the original values from which they were calculated. And they remind us there that every measurement has errors, and we have to pay attention to those errors and categorize those errors. And then we have the final principle in the chapter here, which is principle 15. And this one says that with an understanding of the limitation of the original survey descriptions, modern technology can be used to support weak or questionable evidence quickly and with reasonable cost. It cannot be used as a substitute for evidence. And what follows there, I'm going to read through too. It says that modern technology is not a final answer to retracements, but modern technology and its resulting instruments can be excellent tools to aid the modern-day surveyor, primarily in two areas. First, number one, creating modern measurements for inclusion in modern descriptions that will provide the retracing surveyor of tomorrow with precise measurements with little or no uncertainty for retracing. I've said when it comes to following footsteps that you need to practice that you leave footsteps too. And then secondly, number two, giving credibility to weak or inconclusive evidence. So as I said, this is a very good section to end up with. It shows that technology is important, and surveyors, as we know, have embraced technology, and we need to be experts of the technology, but we can't let technology take the place of evidence. And so this last section here shows us how we can use modern technology wisely as we do our retracements. So make sure you read through that entire section. There's some very good information in there. So that takes us to the end of the chapter, and for this concluding slide here, I want to read through the brief conclusion, section 4-16. It says that this chapter is not written to discredit technology. It is written in an attempt to indicate that new technology and its results should not be used to the exclusion of higher and more conclusive evidence. It should not be used to the exclusion of all other evidence, but it should be used along with other technological tools such as the transit compass chain or any other of the tools as a supplement to help support better or contradictory evidence that cause the surveyor to ponder and to have problems evaluating the evidence recovered. And it says there, boxed off, the statement that's bolded is technology by itself is not evidence. It is the resultant measurements from modern technology that can become evidence to corroborate lesser evidence that is conclusive by itself. So that concludes the lecture, and in summary, the materials that we covered included principles to be applied to modern technology, applying technology to evidence, original corners control, original survey controls, the standards of creation control retracements. We got into errors in original surveys and the effect of standards. We got into original corners based on evidence and not new measurements. We talked about original evidence superior to modern measurements. Got into technology and setting lost corners. Talked about coordinates in corners, corners controlling over lines, that we need 2 points or corners to make a line. And then we ended up finishing the lecture up talking about using modern technology wisely. So there is an assignment for you out there, and there's also the lecture quiz, and so you'll be hearing from me soon with the next lecture.